Okay, in this video we're going to look at finding compositions of functions, and we're going to make sure we understand all the notation involved with composition of functions, and then how to evaluate compositions of functions. So the notation, which you see right here, okay, when you see, this looks like an O, but it really isn't. So I kind of call it fog and goth, but this open circle does not mean multiplication. It means we're putting the function g into f. So this means g into f. And if we just change that order, and this is not commutative like multiplication because it's not multiplication, here we're putting f into g. And this composition can be done with a multiple number of functions. So this notation down here just shows how you could put 3 functions together. We're going to do some examples here. So let's say we have these 2 functions defined as f of x is the linear function, negative 2x plus 4, and g of x is another linear function, 5x minus 2. We want to find f of g of 2. So we always work on the inside first. So this says to find function g when x is 2. So we're going to find g of 2. Well, we've already done this. G of 2 means we replace this x with a 2 and this x with a 2. So that would be 5 times 2 minus 2, which will give us a value of 8. So this would turn into f evaluated at 8. So now we look at function we call f of x. So we're going to take out the x and put the 8 in. So negative 2 times 8 plus 4, and we get an answer of negative 16 plus 4 is negative 12. Okay, example B in this set, we're still using the f of x and the g of x defined at the top. So this is just using the different notation. So the order is important here. So this is saying we're putting f into g. So another way to write this would be g of f of negative 3. So this says that we need to evaluate function f at negative 3. Then we have to take that answer and evaluate function g with that answer. So let's do f of negative 3 first. So f of negative 3, we're going up to our rule for f of x. It says that we take negative 2 times whatever we're replacing x with and adding 4. 6 plus 4, so we get 10. So we're going to take out that f of negative 3 and put its value in, which is 10. So now this simplifies into g of 10, or function g evaluated at 10. So now we're looking at function g of x, which says that we take 5 times, in this case we're using 10 for x, so 5 times 10, 50, minus 2. Run out of space here. So 50 minus 2, our answer is going to be 48. Okay, so we're going to do C and D. And now the difference here is that we're not using a value or a number for x. So this answer for C and D is going to be another expression. So the notation in C says that we're going to put function g into function f. So g is the quantity, or g of x is the quantity 5x minus 2. So now we're evaluating function f using 5x minus 2. So that would be I'm using function f, which says I take negative 2 times whatever x is. Well, now our x is the quantity 5x minus 2 and adding 4. So now we just have to simplify this expression. We'd get negative 10x plus 4 plus 4. So the answer will be negative 10x plus 8. So the answer is another expression. So now we're just going the other direction. Now we're putting f into g. So instead of f of x, we're going to write quantity negative 2x plus 4. So this says we evaluate function g using that quantity. So it's 5 times that quantity and now we just need to do the algebra. Negative 10x plus 20 minus 2. So we end up with negative 10x plus 18. Remember, like I said in the beginning, don't confuse this with multiplication, which would be commutative. Notice when we change the order, f of g of x and g of f of x, notice they are not equivalent expressions. So you really have to pay attention to this order. All right, let's look at example 2. We're doing the same thing. We're putting these functions into each other, paying attention to order. We're just now starting with a new function for f and a new function for g. So if I have f of g of x, that means I'm evaluating f of x by whatever g of x is defined at, which is 4x minus 1. So f of x says that I take 2, square whatever my x is, and then add 3. So to simplify this, I just need to do the algebra. I would square this, and my final answer will be 32x squared minus 16x plus 5. I want you guys to pause the video and try B. Okay, so check your work for B. So we're plugging f of x into g of x. The rule for g of x says we take 4 times whatever our x is, subtract 1, distribute, combine like terms, and we get the new expression 8x squared plus 11. All right, let's look at example 3. So f of g of x, so we're going to evaluate f of x using whatever the expression is for g of x. So now I'm going to follow the rule for f of x. Which says I take whatever the x is and square it and add 3. So that will end up being x to the 4th minus 8x squared plus 16 plus 3, which will be x to the 4th minus 8x squared plus 19. Okay, I want you to complete example 3, letter B, as part of your homework. So we're going to go down to example 4. And for example 4, f of g of x. So we're putting g of x into f of x. So now we're going to take f of x, and everywhere there's an x, we're going to put the quantity 4x. And then we could simplify this by expanding it. So we'd end up with 16x squared minus 20x and plus 8x, and then minus 10. Combine your like terms. And we get the trinomial 16x squared minus 12x minus 10. G of f of x, so it'll be function g evaluated at, and I'm going to expand that, so it would be x squared minus 5, and plus 2 will be minus 3x minus 10. So now g of x says I take 4 times whatever that is, so it'll be 4 times that quantity. So my answer will be 4x squared minus 12x minus 40. Okay, let's jump to example 5. In example 5, A and B, we have this composition of 3 functions. And just to show you where this comes from, we won't do the composition of 3 functions that often. There are functions that exist that are a result of the composition of 3 functions, but we won't deal with too many of those in this course. So I'm just going to briefly show you where this comes from. So again, remember working that h of x is the inside function, g is the next layer, and f is the outer layer. So this says we evaluate g using h of x. So h of x was 4 minus x, so we put that into g. And function g says we square it, so then we had 4 minus x squared. Function f says we take 2 times it and subtract 1. And you could just leave it in this form, or you could expand it. But we won't spend a lot of time with the composition of 3. I am also going to assign C for homework and D for homework. I'm going to end with this last example here, F, which is where we have that composition of 3 functions, but instead of using expressions, we're actually using a value. This is certainly something you should be able to do. So this says to evaluate f of negative 1, we work on the inside and then work our way outside. So we're going to do f of negative 1 first. So f of negative 1, I'm following the rule. 2 times negative 1 will be negative 2 minus 1, I'll get negative 3. So now this turns into h of g evaluated at negative 3. So now we're going to find g of negative 3. Well, g of x says you square whatever x is, so negative 3 squared is 9. So now this turns into h evaluated at 9. Function h says we take whatever x is and subtract it from 4, so h of 9 will equal 4 minus 9 is negative 5. And that's our final answer for that evaluation. So you need to do example 3, letter B, example 5, C, and D.